Hello everyone, myself Khyati Vyas from JMP English Medium Saraswati Group of Education. Today I am conducting this session for grade 6, subject SS. We are dealing with Geography chapter number 3, Motions of the Earth, and this is my session number 2 for this chapter. So kids, in our earlier session, that is session number 1, I discussed to you regarding the motions that the earth shows. What do you mean by motions? Yes, the movements that the earth shows are called the motions of the earth. Excuse me. So how many types of motions does the earth show? What type of movement does the earth show? Yes, the earth shows two types of motion, that is rotation and revolution. What do you mean by rotation? What do you mean by rotation? Yes, the movement of the earth in its fixed axis is called rotation. Rotation takes 24 hours and it causes changes in day and night. Rotation also causes changes in occurrence of day and night, then rise of the sun in the east and it sets in the west, then deflection of the wind, that is the speed of the wind, sometime it increases, sometime it decreases, then gives us 24 hours, then occurrence of tides, that is twice in a day, in the oceans and the sea, the high tides and the low tides, twice in a day, that changes you can notice. And the earth, it rotates from west to east, and that is why we feel that the heavenly bodies are going from, yes, they move from east to west, right? So all these changes are due to the rotation. The other movement that the earth shows is the revolution. The movement of the earth around the sun in a fixed orbit. What is orbit? Yes, the fixed path on which the earth moves, it's called its orbit. So this is revolution. It takes 365 and a quarter day, or you can say 365 days and 6 hours to complete one revolution. And it causes changes in season, right? Yes. Then what are the effects of revolution? Firstly, variation in the variation in the length of day and night. In winters, days are short, long are the nights, and in summer, days are long, nights are short. So this is because of revolution. Then distribution of heat over the earth, right? Heat over the earth, because whichever part is facing towards or whichever part is closer towards the sun, then that part, if it's the northern hemisphere, then northern hemisphere will have summer, and southern hemisphere, since it's away from the sun, then it has winter. See here, just a general idea that I'm giving you. Here is the sun. So now what happens? Northern hemisphere, North Pole is tilted towards the outer side. So northern hemisphere, this part of the earth, this is the equator passing. So since southern hemisphere, that is the down part is towards the sun, so they are having summer, but northern hemisphere will have winter. Similarly here, if you see, the northern hemisphere is towards the sun and southern hemisphere, that is towards the south pole, it is away from the sun. So this part, the upper part, northern hemisphere part will have summer and southern hemisphere will have winter. This is because of the revolution. Then occurrence of season. How the season changes. It is all because of that. Now, as I told you that revolution, to complete one revolution, it takes 365 days and 6 hours. So what I told you regarding this 6 hours? Yes, we accumulate this 6 hours for 4 years. That is 6 hours into 4 years. It will become 24 hours. 6 into 4 is 24. And this 24 hours we refer as one full day, because one day is equal to 24 hours. So every 4 years, one day is added. So that year will have 366 days. And that year is called a leap year. What is it called? It is called a leap year. And this day is added in the month of February. So normally February has 28 days, but if it is a leap year, then February will have 29 days. All this we have already discussed. In today's session, we will discuss in detail regarding the effects of revolution. Firstly, we will begin with the variation in the length of day and night. Why there is variation in the length of day and night? As the season changes, the length of the day and night also change. Why is this change? The variation in the length of day and night occur because the earth revolves around the sun in its fixed axis, always inclined in 66.5 degrees. Inclined means tilted. See, I told you that this line is not 90-degree line. It is tilted to 66.5 degree. It is tilted to 66.5 degree. At the equator, the variation is minimum and the days and nights are equal length throughout the year. Near the equator, since this part moves away from the sun, right? Yes. So since this part is away from the equator, it will show you great variation in day and night. But since equator receives the direct rays of the sun almost throughout the year, so here the places that are located near the equator will not have much variation, will not have much difference in the length of day and night. It is almost equal throughout the year. So, always from the equator, the days are longer in summer and the nights are longer in the winter. So if you are away from the equator, then in summer days are long and nights are short. At the poles, the variation is maximum. So at the poles, North Pole and South Pole, near the North Pole and South Pole, the variation in length for day and night is maximum, means very much higher. Right? You can see the difference. You can notice the difference because the difference is so much. That is maximum difference. Near the equator, minimum, and near the poles, maximum differences is noticed. At the poles, the variation is maximum. There is continuous daylight for 6 months during summer and continuous darkness for 6 months during winter. Say for example, now here the North Pole is towards the sun. So however this earth rotates, but this North Pole region is always having the sunlight. It is summer here. Say summer solstice I have written. I have explained to you what is solstice. You already know, but still. But see here, even if it is rotating here round and round and round the earth, right? Even if it is rotating round and round and round, still North Pole is always facing the sun. So the North Pole will have continuous daylight. Even if it is night, the light is there. It is bright. And here if you see, North Pole is away from the sun. So even if the earth is rotating round and round, but still sun's light will not reach here because the North Pole is tilted. That means it is not getting the light of the sun at all. So continuous for winter. See, I have written winter solstice. So for North Pole it is winter. And that is why here for 6 months they will not have any daylight, complete darkness. Even during the day it is dark. So this happens Because of this revolution. Revolution is movement of the earth around the sun. Movement of the earth around the sun. Now next, duration of heat over the, distribution of heat over the earth. This you already know. On the equator, the heat received is maximum because of, it gets direct rays of the sun. See, all the parts, equator will get direct rays of the sun. So places near equator will have lot more heat than the places which are away from the equator. The parts of the earth that is tilted towards the sun receives vertical rays of the sun, while the other part receives the slanting rays of the sun. So whichever part is tilted towards us, see here, now equator will get the sunlight, but here the parts in the southern hemisphere, that is Tropic of Capricorn, Antarctic Circle, they will get more heat. And here in the northern hemisphere, whether it is Tropic of Cancer and Arctic Circle, they will receive the heat but less heat. But when you say this side, here, the southern hemisphere will get less heat and northern hemisphere, the Tropic of Cancer, Arctic Circle, they will get more heat. This is because of revolution. So the part of the earth that is tilted towards the sun means which is towards the sun. See here, North Pole is towards the sun. Here you can say South Pole is towards the sun. Sun is here. So if South Pole is towards the sun, then they will receive more heat. If North Pole is towards the sun, they will receive more heat. So vertical rays give more heat than the slanting rays. Vertical rays means straight rays will give more heat than the slanting rays. Right? Can you say why? Yes, this is because vertical rays are direct and concentrated in smaller areas. It travels only small distance. Since just a straight line, it travels only small distance. And vertical rays, since it is traveling for a longer distance, then here they will get, it will become cooler. The rays of the sun, the heat becomes cooler. So here in the textbook also they have shared a picture. You can see that, right? Yes. Now, next, they have also shared that, the area is concentrated in smaller while the slanting rays are spread out over a large area. Also, the vertical rays pass through the shorter distance of the atmosphere than the slanting rays. As I explained to you, vertical rays travel, that is straight rays will travel to a short distance and slanting ray will have to travel for a long distance. Thus, they lose their heat. What did I explain? Shorter distance and longer distance. Say for example, if I take this, see here, this is the straight line. It's just this much. If I put this slanting, then it will travel to a bit longer distance. So if the light is traveling or if the ray of the sun is traveling to a longer distance, then the heat will decrease. And if it is traveling to a shorter distance, then the heat is more. Here they have also shared an additional information. The midday sun is never overhead beyond the tropics. Midday sun is in the noon. The sun is not over. We say that in the afternoon the sun is right above our head. But beyond the tropics, so Tropic of Cancer and Tropic of Capricorn, beyond the tropics, so other than that, in the area between Tropic of Cancer and Tropic of Capricorn, covering the equator also, only in these places it is right above our head in the midday. The sun is right above our head. But beyond the tropic, it is not above our head. So, only places situated in the tropical zone, that is between the Tropic of Cancer and the Tropic of Capricorn, can see the noon sun directly overhead. Places situated beyond the two tropics can never see the sun directly overhead. the places which are beyond the tropics, that is in the North Pole. After you cross Tropic of Cancer, you will never see the sun exactly over your head in the noon. And in the southern hemisphere, beyond Tropic of Capricorn, if you go, you will not see 12 o'clock noon, the sun exactly on your head. So this was all regarding the occurrence of the heat over the distribution of heat over the earth. Now changes in season. There are two factors which result in the occurrence of different seasons in different times of the year. Why the seasons are different in different times of the year? You have summer season at a fixed time, winter at the fixed time, monsoon at the fixed time. So why is this so? First one, the revolution of the earth, and second one, the inclination of the earth axis at the fixed angle and direction. Inclination is the tilted part. Since earth is tilted, so that is why this changes happen, and because of revolution. The figure given below will help you understand the occurrence of seasons. See, this is a figure that is also given in your book. The figure you can see right on the board. Yes, it is also given in your book. It shows the position of the earth in its path of revolution on 4 different dates. Look at the 4 positions carefully. First one is 21st June. So where is it? 21st June. Let me mark it for you. This is 21st June. Then you are having 23rd September. Then you are having 22nd December. And 21st March. These are the different dates that we are going to learn now. Now here, 21st June. On this day, the northern hemisphere is inclined towards the sun. Inclined means northern hemisphere. North pole is towards the sun. So this northern hemisphere is towards the sun now. Southern hemisphere is away. Northern hemisphere is inclined towards the sun. The sun's rays fall vertically on Tropic of Cancer. Since the rays of the sun are direct and the daylight for the longer hours, it is summer in northern hemisphere. Since northern hemisphere is inclined towards the sun's rays fall directly on the Tropic of Cancer, and northern hemisphere will have summer at that time. 21st June is the longest day and the shortest night of the year in northern hemisphere. So in northern hemisphere, 21st June will have the longest day and the shortest night. But if you talk about southern hemisphere, that is on 21st June. In southern hemisphere, the condition is just opposite. It is not the same. This region is turned away from the sun and thus receives the slanting rays of the sun. Daylight is for short hours and hence it is winter. Since this is away from the sun, see, northern hemisphere is towards the sun. Southern hemisphere goes away from the sun. That is why here in southern hemisphere it is winter and the days are, or the daylight is for shorter hours. Next, talking about 22nd December. The condition has changed. Now northern hemisphere is away and southern hemisphere is towards the sun. So position changes. On this day, the southern hemisphere is inclined towards the sun. Inclined means it is towards the sun. See, southern hemisphere is towards the sun, northern hemisphere went away. So here the position has changed. The sun's rays fall vertically on Tropic of Capricorn. Here, Tropic of Capricorn will receive the highest rays of the sun. So it is summer in southern hemisphere. Places here have long day and a short night on the year. So on this day, southern hemisphere will have the longer day and shorter night. 22nd December, longest day and shortest night. On the other hand, the northern hemisphere is turned away from the sun. Here northern hemisphere is away from the sun. It is not towards the sun, it is away from the sun. Right? So, here it receives the slanting rays of the sun. Days are short and hence northern hemisphere will have winter. India is in northern hemisphere. So, December, 22nd December, northern hemisphere has winter. So that is why, since we are located, India is located in northern hemisphere, so India will have winter, right? Next, talking about 21st June and 22nd December are known as the summer solstice and winter solstice. So here 21st June and 22nd March, they are called summer solstice and winter solstice. You can see, right? Summer solstice and winter solstice. This is for northern hemisphere, right? Thus, the word solstice means sun standing still. Sun standing still. That is, sun is at a fixed path. Next, talking about 21st March. On this day, the sun shines vertically over equator. Here, the sun shines vertically on equator means straight to the equator it shines. Here and here. Vertically. It shines vertically over the equator. Direct. Therefore, all the places on the earth have equal days and nights. And that is why here we have equal day and night. No changes in day and night. Because here, the sun rises or the sun rays fall directly on the equator, not on the tropics. Here it falls on the tropics, right? Here you have Tropic of Capricorn and here you have Tropic of Cancer. The sun rays fall on the tropics. But in these two places, that is on 21st March and 23rd September, the sun rays falls only on the equator, direct equator, right? So this place here throughout the earth, everywhere you have equal day and night. The northern hemisphere has spring while the southern hemisphere has autumn. So on 21st March, northern hemisphere will have spring season, southern hemisphere has autumn season. And 23rd September, that is here, this part, it is again opposite. On this day, again sun shines vertically over the equator, causing equal day and night. Again equal day and night because the vertical rays of the sun fall on the equator. And at this time, northern hemisphere has autumn and southern hemisphere will have spring. We live in northern hemisphere, so for us, March is spring and September will be autumn. But places in southern hemisphere, they have September as spring and March as autumn. Right? The 2 days, 21st March and 23rd September are called equinoxes. They are called equinoxes. Means equal nights. They have equal nights. As the sun is overhead at the equator and days and nights are of equal in length throughout the world on these 2 dates. Why equinoxes? Because on these 2 dates, all the parts on the earth will have the equal length of day and night. 21st March is called spring or vernal equinox and 23rd September is called autumnal equinox. So, here 21st March is called spring equinox. Here I have mentioned, or you can say also vernal equinox, and 23rd September is called autumnal equinox. Autumnal equinox. Right? Next, they have given to you a table in which they have mentioned the dates, that is 21st June, 23rd September, 22nd December and 21st March. Now looking into this diagram, they have also explained to you that on which day, which hemisphere will have what type of climate or what type of changes. You can go through the table. But the rest of the part I have already explained to you through the video. So here we come to the end of the chapter. Along with this video, you will receive your CW part 2 and chapter end worksheet. Okay? So I hope you will complete your work on time with good handwriting and no spelling mistakes. So if you have liked this video, please click on the like icon. See you in the next session. Bye.